Hey guys, welcome back. So for today we are taking and looking at 14-1. So this week you guys have two lessons, 14-1 and 16-1. Yes, we're kind of skipping around. We're doing what's necessary that you need to have done. So today we're going to be looking at line plots. So how can you organize data using a line plot? So first of all, a line plot shows data along a number line, and each X represents one number in the data set. An outlier is any number that is very different from the rest of the numbers. So it's going to be significantly larger or smaller than the rest of the data points that you're taking and working with. So the table shows the average lifespans of certain animals in years. Make a line plot to organize the data. So we've got numbers we've got 7 years for a kangaroo, 8 years for a chicken, 9 for a fox. That should say 10, sorry, got erased apparently. 10 for a cow, 10 for a wolf, 10 for a deer, and 18 for a black bear. So what we have to take and do is we're gonna make our number line. So I'm gonna go 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And yes, you do have to include all of those. We're dealing with a number line. We're not going to skip around. So now what we want to do is plot each of these values on our number line. So kangaroo had 7 years. So that's an 8. Sorry. So there's our kangaroo value. Chicken was 8 years. Fox was 9 years. We had a cow, and we had a wolf, and we had a deer, all for the 10 years. And then all the way up here at 18, we have the black bear. So there is our line plot. So that's what you guys are taking and doing. And I will tell you on your assignment, you're probably going to notice it's worth a lot of points. Each one of the X's is a point. So you have to make sure you include all of them and don't jump around on your number line and only give me 7, 8, 9, 10, 18 for a number line. That's not going to show the information. So for our first question, what is the most common lifespan of the animals? So looking, what's the most common that we had? 10 years, yeah. So there were 3 of them that all had a lifespan of 10 years. Excellent. What's the longest lifespan we had? 18, excellent. What's the shortest lifespan we had? 7, excellent. And last but not least, identify any outliers. So based on this data, are there any outliers? Is there one number? So remember, an outlier is any number that's very different from the rest of the numbers. So based on that, looking at this, are there any outliers in the data? Is there one that's very, very different? Yes. So 18 is an outlier. So it's further away from all the values. So pretty much when we have gaps in our data and then we have a new point, that's typically going to be your outlier. Actually, it will always end up being your outlier if there's a large gap. Now, if you have just a gap of 1, so let's say we went from 7, 8, skipped 9, and then went to 10, and then maybe had 1 and 11, that was it. 10 and 11 would not be considered outliers just because there's one value skipped, especially if there's a significant amount of data there, then it wouldn't be considered an outlier. Okay? Alright, we're going to look at a few more with this. So, how many giraffes are 14 feet tall? So we already have a line plot made. And so we're going to use this line plot to answer these questions. So how many are 14 feet tall? Well, we go to the 14 and then we look. There's 2 X's. So that means we have 2 giraffes. What about the next question? What is the most common height of the giraffes? So what's the one that's appearing most often? Which one has the most X's on it? 15, So 15 feet. And then how tall is the tallest giraffe on the line plot? 18, excellent. And last but not least, is the number 18 an outlier? So this kind of ties into what I was just saying on that last one. Obviously, we do have a gap in our data, so we're going from 14, 15, 16. We skip 17 and then go to 18. But we have two values at 18. So is 18 really an outlier? No. So, no. Multiple values of 18 and data is close, even though it has gaps. So even though it has gaps, it's really close. There's not a significant gap between these, so I would not consider 18 an outlier. All right, so this is what a portion of your assignment is going to be, is taking and making dot plots. You may be asked questions about dot plots, so just not dot plots, line plots. So you're going to be taking and answering questions and making line plots. Make sure you include all of your data points and make sure you have your number line nicely wrote out. Okay, for the last thing that we're looking at on this, pets in Paulina's pet shop have the following weights. The dog's weights are in pounds. How can we organize the information into a frequency table and a line plot? So we've got this table and we've got 7 1/4, 2 1/2, 12 1/4, 12 1/4, 6, 2 1/2, 11 1/2, 12 1/4, 2 1/2, 12 1/4, 12 1/4, 6. So we've got a lot of data in here and it's kind of all over the place. So what we want to take and do is make what's known as a frequency table. So that's where we put all of these numbers in numerical order and then we list how many times each of them shows up. So I'm going to make my frequency table over here. So this is going to say value frequency. So our smallest number is the 2 1/2, and we have 1 here, 1 here, and 1 here. So we've got a frequency of 3. Then our next smallest number, whoops, sorry, you can't see that. Our next smallest number looks to be our 6. So we've got a 6 here and a 6 here. So 6, it's got a frequency of 2. Next we have the 7 1/4. And it looks like we just have the 1 of that. Next we go to the 11 1/2. We also only have 1 of those. And last but not least, we have the 12 1/4. And we've got 1, 2, 3, 4, 5 of those. Sorry, reflection's bad. So this is what's known as a frequency table. So it's where we include all the values of our data set and we write the frequency of all of them occurring. It makes it a little easier to take and see all of our information and then make a dot plot from that. So here is our line. So we've got we're going to have 2, we have 3, 3 1/2, 4, 4 1/2, 5, 5 1/2, 6, 6 1/2, 7, 7 1/2, 8, 8 1/2, 9, 9 1/2, 10, 10 1/2, 11, 11 1/2, 12, 12 1/2, 13. Okay, so once again, we do have to have all of our values. So we had 3 that were at a 2.5, so 1, 2, 3. We had 2 that were at 6. We had 1 that was at 7.25, so this right here in between the 7 and 8 is 7.5. So our 7.25 is going to go halfway between the 7 and 7.5. Then we have 1 that was at 11.5. And then we have 5 that were 12.25. So just like with the 7.25 going halfway or going in between the 7 and the 7.5, we're going to go between the 12 and the 12.5. So we've got 1, 2, 3, 4, 5. So this is the second part of your assignment. You're going to be making the frequency table. Yes, I expect to see all of this wrote out with the frequencies, and then you're going to make a line plot. So it's going to be worth a lot of points. So your keyword for this lesson is line plot. If you have any questions, feel free to send me an email. Remember, your keyword is line plot. Yes, I expect to see all of these X's. Yes, when you're doing the frequency table, I expect to see it all wrote out like this. Make sure you're organized. This assignment's going to be worth quite a few points because there's a lot of things that you have to make sure you include, otherwise it's just not accurate. Okay? Alright, have a wonderful week. Happy mathing, and I hope you all have a wonderful, wonderful summer.